January 28, 1986, 11:30 a.m. On the morning of January 28, 1986, Launch Complex 39B at Cape Canaveral did not look like the gateway to the stars. It looked like a graveyard. A polar air mass had swept down from the Arctic, settling over Florida with a violence that no one had predicted. The temperature on the launch pad was 29 degrees Fahrenheit. In the shadowed areas, it was as low as 8. Icicles, some of them 2 feet long, hung from the handrails and the gantry pipes. The water troughs, designed to suppress the roar of the engines, were frozen solid. Inside the crew cabin, 7 astronauts were strapped into their seats, waiting for the final go. They were eager. They had no idea that the decision to kill them had effectively been made 12 hours earlier, in a smoke-filled conference room in Utah. The danger wasn't the ice on the tower. It was a tiny rubber seal, less than 1/4 of an inch thick, hidden deep inside the steel casing of the solid rocket boosters. This is not just the story of an explosion. It is the story of a meeting, a specific sequence of bureaucratic decisions that ignored physics. This is the final 24 hours of the Space Shuttle Challenger. January 27, 1986, 12:30 p.m. To understand why the Challenger launched, you have to understand why it hadn't launched yet. The pressure was not atmospheric. It was political. NASA was trying to prove something impossible, that space travel could be routine. They called it the space truck. They promised Congress a launch every 2 weeks, but the schedule was slipping. Challenger Mission 51L had already been delayed 3 times. The media was mocking them. And most critically, President Ronald Reagan was scheduled to give the State of the Union address on the night of the 28th. NASA executives didn't just want a launch, they needed a launch. They wanted the shuttle in the sky while the president was speaking to the nation. But on the afternoon of January 27th, a mundane, stupid problem halted the countdown. A stripped screw on the exterior hatch handle, a simple $5 piece of hardware, took hours to drill out. By the time they fixed the hatch, the wind had picked up. The launch window closed. That delay was the first precursor. If they had launched on the 27th, the temperature was 53 degrees. The crew would have lived. But because of a stripped screw, the launch was pushed directly into the path of the Arctic front. January 27th, 2 p.m. While the crew climbed out of the shuttle, frustrated by the delay, weather reports began to hit the desks of the engineers at Morton Thiokol. Thiokol was the contractor responsible for the solid rocket boosters, the 2 massive white towers strapped to the side of the shuttle. These weren't liquid fuel engines that could be turned off. They were essentially giant Roman candles. Once lit, they burned until they were empty. The boosters were built in segments, stacked like cups. The joint where 2 segments met was the weak point. To keep the burning gas, which reaches 5,000 degrees, from leaking out, the gap was sealed with 2 rubber gaskets, the O-rings. But rubber has a fatal flaw. It has a glass transition temperature. Think of a rubber ball. At 70 degrees, it bounces. At 30 degrees, it becomes hard. At 20 degrees, it can shatter like glass. The engineers knew that below 53 degrees, the O-rings might not stretch fast enough to seal the gap. If the gap wasn't sealed in the first millisecond of ignition, the flame would blow past the rubber like a blowtorch. January 27th, 5:45 p.m. This is the moment history pivoted. A teleconference was convened. 3 locations were on the line: the NASA launch team at Kennedy Space Center in Florida, the NASA management at Marshall Space Flight Center in Alabama, and the engineering team at Morton Thiokol in Utah. The mood in the Utah room was heavy, thick with cigarette smoke and coffee. 4 senior engineers, led by Roger Boisjolet, were staring at the charts. They knew what the cold would do. They officially recommended a no-go. They told NASA, do not launch. Boisjolet slammed his charts down on the table. He explained that tomorrow, it would be 24 degrees colder than their worst-case scenario. NASA was appalled. They were looking at another delay, another embarrassment. Lawrence Malloy, a NASA manager, attacked the engineers. His words were recorded in the notes of that night. He said, "My God, Thiokol, when do you want me to launch? Next April?" They drilled the engineers. They demanded proof that it would fail. The engineers couldn't prove it would fail. They could only prove that it was unsafe to try. January 27th, 8 p.m., Jerry Mason, a senior executive at Thiokol, turned to the vice president of engineering, Bob Lund. Bob had initially agreed with the engineers. He had voted no. Mason looked at him and delivered one of the most infamous sentences in the history of corporate negligence. He said, "Bob, take off your engineering hat and put on your management hat." They told NASA the recommendation had changed. The launch was a go. When the meeting ended, Roger Boisjolet went home. He told his wife, "We are going to kill those people tomorrow." January 28th, 7 a.m. The sun rose over a frozen landscape. NASA sent out the ice team. The freeze was so severe that the fire suppression system had frozen, coating the gantry in thousands of pounds of ice. They reasoned the ice would likely bounce off. NASA decided it was acceptable. For the second time in 12 hours, a major contractor said no, and NASA said, go. 11:38 a.m. The crew was strapped in. The cabin was warm. Commander Scobie and pilot Michael Smith ran through the final checklists. It was estimated to be 28 degrees. Inside the booster joint, the rubber O-rings were hard as rock. T-minus 10, 9, 8. At T-minus 6.6 seconds, the main engines ignited. The entire stack swayed forward, then twanged back to vertical. 3, 2, 1, and liftoff. At the exact moment of ignition, the solid rockets lit. The pressure inside the booster went from 0 to nearly 1,000 psi in milliseconds. Normally, the pressure pushes the O-ring into the gap to seal it, but the rubber was frozen. It moved too slowly. It was milliseconds too late. A puff of black smoke, dark as ink, spat out of the side of the right booster. The seal had failed. For the next 40 seconds, the Challenger was flying on a temporary, fragile plug of melted aluminum. If the air had been smooth, they might have made it to orbit. But fate wasn't done. T plus 58 seconds. The Challenger passed through max Q. At that exact moment, the shuttle flew through the strongest wind shear ever recorded during a launch. The vibration broke the plug. Instantly, a tongue of flame, hot enough to melt steel, erupted. It acted like a blowtorch, pointed directly at the giant tank filled with 500,000 gallons of liquid hydrogen. T plus 72 seconds. Pilot Michael Smith likely saw a flash of orange light on his window. Ground control spoke. "Challenger, go with throttle up," Commander Scobie replied. "Roger, go at throttle up." 1 second later, the bottom of the hydrogen tank failed. The massive cloud of vapor ignited. At 46,000 feet, the Challenger was torn apart. The last voice recorded was Michael Smith. He said only 2 words. "Uh-oh." The shuttle disintegrated, but the crew cabin, the reinforced pod where the astronauts sat, was built to survive extreme forces. Forensic analysis suggests the cabin survived the breakup intact. They did not die instantly. The cabin continued to fly upward on its own momentum, reaching a peak of 65,000 feet before gravity took hold. It fell for 2 minutes and 45 seconds. When the wreckage was recovered from the ocean floor, emergency oxygen packs were found activated. They had been turned on manually. The pilots were alive, conscious, and falling. Fully aware that the ship was gone, it took 73 seconds to destroy the Challenger. But the disaster didn't happen at 11:39 a.m. It happened the night before, at 10:30 p.m. When a manager told an engineer to take off his hat, it happened when a strip screw delayed a launch into a cold front. It happened when the definition of safety was rewritten to fit a schedule.